So, welcome. Welcome to our talk. So you guys created this application, Bitbox, right? And it does an awful lot of really cool things, as you guys saw. It plays music. And there was this cool thing that kind of happened there when you kind of walked on stage and you kind of tap these guys together. So this is really kind of a great kind of example of a great Windows 8 application, right? There's, you can get to type, you can tap on things to make things happen, right? We saw some of the proximity things. So Adrian, why don't you tell us a little bit more about what you had to do in order to make the proximity stuff work?
Yeah, so we use the proximity API, which is really easy to use. If we can switch to the virtual view.
Oops, thank you.
Okay, so yeah, basically with the proximity API, we just register callbacks. So in the first line here, we can say, like, basically on device arrives when two devices are in contact, we can register the device in contact callbacks to do like something's going on and post or receive a message.
Right.
If we go back up a little bit, we can, the on-peer connect progress, basically, that will be called this thing called peer finder, which is this awesome magic thing that happens in the Windows runtime, which basically, once you say peerfinder.start, it'll start up this service that will basically start up a connection through either Bluetooth, TCP/IP, or Wi-Fi direct. So once you've established that, we just have this peer connect progress down here, and basically we are given a socket that is created through whichever of those three is fastest, and then we can just read and write to the socket, and it just sustains the connection throughout the whole session.
Very
which
cool.
is awesome.
Yeah. So essentially, once you got this thing set up, right, your tablet was transmitting data off to Sam's tablet, right, and all of the sound was being played.
Yeah, and that's when the music got bad. So.
Cool.
Yeah.
So Sam, why don't you tell us a little bit more about what you had to do to make all of the audio stuff happen inside of the app?
Yeah, well, when we started off, we were playing with the HTML5 media elements, and we discovered that they were incredibly responsive. So we came up with the idea of doing a media app. And in order to get everything to be on the same beat, we actually wrote a clock that allowed us to schedule function callbacks that would all be executed on the same tick. And in order to do that with some sort of like high efficiency, we used a web worker. So you can see here, we create a new web worker, add an event listener so that you can communicate in between the threads, and then post a message to it to start the clock and set the period of each tick.
Right.
Then every time the clock gets called, it executes all of the callbacks. And here's the tick worker. Basically, it just parses a message from the other thread and posts a message back to it on ticks. So you can control it from the main thread while it's executing on its own and executing on regularly scheduled intervals.
That's awesome. Cool. So thanks. This is a really awesome app, right? Like this is one of my favorite things. I spend a lot of time, playing with this in my room. So why don't we bring up on stage all of the other interns that worked on the applications that you guys have all been using. And let's give them a big round of applause. So my name is John Lamb. I'm the intern den mother here at Microsoft. In my day job, I'm a lead program manager on it's called the Runtime Experience team, but we're the guys that made the plumbing for the Windows runtime. But for my summer project, I had the great experience of taking this fine young batch of folks and a bunch that didn't make it here, right, because we had budget constraints, to come out here to show you and share with you guys, what the kinds of applications that they wound up building. So with that said, why don't we switch over and let's talk to Varun. Varun is up here in the front row. Wave hello. And Varun worked on the news application. And if you guys have been using, playing with your tablets, what you've seen is that there's these live tiles. And as part of what the live tiles are, well, in the news application, you're subscribing to RSS feeds, and you want to have the latest content. So Varun, why don't you tell us a little bit more about what it was like, to build the infrastructure kind of behind the scenes, right, that pumps the data down into the live platform?
Sure, John. Actually, we've been doing this a bunch today because there've been like 2 or 3 notification talks. So if you actually go ahead and tap on the News app, when you on your tablets also go and add subscriptions to your News app, what happens is we have a backend service that's running on Azure because it's now super easy to just run and jumpstart your Azure project. And what we do is the first thing is we get a channel. And the way that we can talk, our Azure backend can talk to your tablets and your tiles and your for Toast notifications and all that is through this channel. So over here we have a quick code sample, and it just goes and talks to the Windows Networking Push Notifications API, and we get a channel, which is just a really, really, really long URI. And there's a bunch of security stuff that you have to set up beforehand when you onboard your app onto the App Store. And so this is just a really dumbed down version of it. And all that we do is just gets the channel URI, and we go ahead and send it up to our Azure service, and that stores it in there for you so that we know which subscriptions you're subscribed to and connecting that to your channels. And on our backend itself, we're also doing constant polls for all the feeds that you guys subscribe to, and we have it going every 15 minutes or something. And it polls those things. It downloads the XML feeds. It checks the latest 5 articles, and also looks at the images and picks the right template. If you guys went to the session today, you saw a bunch of different templates we can use with different text sizes, different images. And so we do a little bit of processing there, and then we push it off to WNS, and it takes care of the rest of it for us.
So when you push off to WNS, right, you're posting a message into it, right?
Yeah, and so the way the WNS works is if you do it through the Windows, there's a new Windows Azure toolkit that's been released, which makes this whole process very easy. But it's basically sending a tiny little XML blob that you see up here. So this is if I were to send a badge, but I mean you can imagine that XML part at the bottom switch to a tile or switch to a Toast notification. And the headers on the top include the authentication, include the security, and then at the bottom it tells you which template you want to use, and then you just fill in the text fields, you fill in the image fields, and when you push that off to WNS, and it's just a simple HTTP post, you get a notification.
Very cool.
And that's
awesome.
it.
Great. Thank you. So moving along, the next application we're going to look at is Mopod. And much like what the newsreader does, it obviously consumes RSS feeds. But the cool thing about Mopod is not only will it consume the RSS feed, right, but it's going to look inside for attachments and turn around and play the podcasts, right, that are inside of the enclosures inside of there for you as well. One really kind of cool thing, Ananya, about Mopod is that when we're looking at the subscriptions that we see here, right, not only can we see them like this, but if I just go off and do this pinch thing, right, we can do the semantic zoom and scroll inside there so we can see the actual details, right, of each one of the podcasts as well. So why don't you tell us a little bit more about how you built that?
Sure. So actually, the semantic zoom was fairly easy for us to focus on because the initial part, getting the core functionality of our app, which was using the syndication API and playback, was very simple to implement. So I'll talk you through semantic zoom. Something that's important to realize is that you're not navigating between 2 different pages, but you're zooming into different sections of the same page. So within the same HTML, we declare a zoomed out view and a zoomed in view, and in line 2, you define semantic zoom as the control that controls these 2. And for the core data, we used one data source to populate both views. So we used an episode master list that would populate episode information into the episode view and feed information related by the feed name into the zoomed out view. So if you look at lines 7 through 16, basically you're defining the data source. So the data that relates to the zoomed out view, the zoomed in view, and the item renderer is essentially the HTML template that renders these items. And coming back to the group by, if we scroll down, that's where you actually declare how the items are related. So there's 2 main functions here. There's key and data. The key is what tells semantic zoom how the episodes are linked. So in our case, the episodes are linked by the feed name, and the data is what contains all the data binding for the HTML templates. And that's it, and you have semantic zoom working.
So it's cool. So it effectively just stamps these things out, right, in a template form, right, based on the information that's sitting inside of the data sources.
Exactly.
Yeah, very cool. And the other thing that you guys do is you also consume some the RSS as well, right? So it turns out that it was a rather simple thing for you guys to go off and implement the RSS consumption as well.
Yes, it was really simple. In fact, all we did was first pass off the RSS link to the background downloader, which then asynchronously downloaded this information, returned the raw XML file to us. We converted the raw XML file to an object and just passed this to the syndication API. So literally lines 15 and 16, just 2 lines of code, and you get all the parsed information you need for the feed.
Very cool. Awesome. Great. Thank you. So moving along, hopefully you guys have had a chance to sit down and play with this game here, right? Which is Copper. And Copper is one of the C++ DirectX games that we have installed on the machine. And the kind of cool thing about this is, we can certainly go spin this guy around, we can zoom in and out. There's a lot of these gestures, these kind of modern gestures that are being added to the game as well. Right, so Jesse, why don't you tell us a little bit more about how you went off and implemented those set of features?
Sure. It turns out it's incredibly easy to add gestures to a C++ project. Using WinRT, the new windowing system, is absolutely the simplest thing I've ever used. Instead of using the standard Win32 message pump, you have to continually process messages, the new system uses an event-based system. So you get pointer events, pointer down, pointer up, pointer moved, and then all you have to do is pass those to the system called the gesture recognizer. And the gesture recognizer is really easy to use. All you have to do is set it up, create an instance of it, it's the first thing there, and then just pass some settings to it, telling it exactly what kinds of gestures you want it to process for you. In our case, we needed to use scale and translate. We also wanted inertia on the scale and translate. You can actually see the inertia when you rotate the gear. When you let go, the gear continues to spin for a little while as it slows down. Very smoothly, very easy. We didn't have to do any extra work to do it. And then once you pass the settings in, all you have to do is register for an event callback, which is right here.
Cool. So inside, so the cool thing about the inertia thing, right, is that, in the event, right, the numbers are going to spin down, right, as the inertia is applied. And you didn't have to do anything in order to get that effect.
Exactly. The function is called the exact same way, regardless of if the user still has a finger down or not. It's the onManipulation updated event, and you get this nice little delta structure, which has a translation, a rotation, and a scale all right inside. And the same function is called the same exact way. You don't have to do any special work, regardless whether it's an actual touch or inertia that's working.
Very cool. Awesome. Thanks. So moving on, we have Ted up next, and Ted had a kind of a unique idea, right, when he first started his internship. When we first met at what we called our Vision Kickoff Day, Ted came up and said, you know what, everyone's building a lot of these consumer applications, but as you can see, Ted's all dressed up in a button-down shirt there. I want to go off and build a business application, right? So why don't you tell us a little bit more about what you did to go off and build your modern rental application?
Yeah, so there's been a lot of interest in using tablets and things for non-shrink wrap software, so for line of business applications. But up until now, there haven't really been the capabilities required to do so. One of the big ones that we came across immediately was the fact that Windows is the only one where you can use those default credentials, so you can actually domain join the machine and then put it in contact with the Dynamics backend and have it manage all those permissions for you from the server without any new code. But we also didn't want to do that in JavaScript because most people who are writing line of business applications know C# and .NET. We wanted to find out what that experience would be like for those developers making Metro-style applications versus traditional WPF or Silverlight apps. So what we ended up finding was that the APIs were very complete, very easy to use, but also that they felt very much like C# APIs. It's kind of intangible, but there's a definite feeling that you get when you're using a library that's written for the language in which you're writing it. And this did not feel like it was some sort of port from JavaScript to another language. It felt like a first-class citizen of the platform in C# and taking advantage of all of those features that were provided.
Very cool. So the code frac that you have in front of us, right, kind of talked a little bit about some of the changes, right, that you had to make.
This was actually the most significant change that we had to make anywhere, which was the addition of the asynchronous stuff and the await keyword. So as they were talking about this morning, this makes it really easy to do asynchronous code and to avoid the UI becoming non-responsive or anything. And C#'s way of doing it makes it really transparent, so you don't have to worry about when you're waiting for tasks to complete or when things are happening. It just manages all that for you. So it was really easy once we sort of got what we were trying to do with the await keyword and what it could do for us to make sure that all of our code, the app stayed responsive no matter what and was doing these long operations to and from the server but without suffering performance-wise.
Very cool. Awesome. Thanks, Ted. So this morning when I woke up, there was like this noise in my room, across the room, right? I had to kind of like stumble across the room and hit things and stuff. So Arturo was responsible for waking me up this morning. So if you look at, oops, not Arturo. So the alarm application was what you created, right? And there was a couple of really cool things about the alarm application. In particular, when you kind of turn on the alarm application and you go back to the start menu and you come across, you'll see that the live tile updates and shows you the time. So why don't you talk a little bit more about how you wound up implementing that?
Right, so I think you just pointed out one of the two things that my app actually does, because it's really simple. All it is basically a UI for toasts, for scheduled toasts, and it has live tile updates too. And it was surprising to find that the way to do that is really simple and really similar. So if you scroll up to the first function.
Scheduled toast?
Yeah,
Okay.
there we go. Yeah, so to create a scheduled toast, you need an XML object to define what's going to be on the toast, and you need a JavaScript date object, which is on the second line in that function, to determine when the toast is going to fire. After you get that, all you do is create a scheduled toast object using Windows API calls and register with the system. That's it. That's all I do when I turn on when you turn on an alarm.
Right.
And then the tile code is pretty similar. You also get the XML to define what's going to be on the tile. You get an expiration time, which is again just a JavaScript date object, which everybody knows how to use. You create a tile object from the system. You set the expiration time, and then you just register with the system, and it appears immediately.
Very cool.
It's pretty simple.
And the other really cool thing that you had inside your application, right, was because you were familiar with doing HTML and JavaScript code from before you came here, right? You used a library a lot before you came here. Why don't you talk a little bit more about the library that you
Yeah, so the Alarms app uses jQuery a lot to do a lot of DOM manipulation. Actually, the event, well, I'm sorry, not the event. The effect of the little string that fades out when you turn on the alarm, that's also jQuery. And it was really cool to find that you don't need anything special to get it to work. You just include it, like in that line that John has highlighted there. That's all you do to get jQuery working. So you can use whatever you know. And for example, there you can see a few examples of, like on the top there, I have the event, which, I'm sorry, the effect that fades out the string. And then on line 11 is a really good example how this integrates into the system, because I have a win.js.ui, that get control call, which is part of the Windows JavaScript API. And the parameter for that is something that's returned by jQuery. So it just works. Works great.
Very cool. Awesome. Thank you. So moving on, something that I check every day, especially when I go wandering around and visiting different places, is the weather, right? I'm like a big weather junkie. And so there's a couple really cool things about the weather application, right? One thing, obviously, as you can all see, it plays a video in the background. And the other kind of cool thing that we also saw was we can go off and create these secondary tiles, right? So when I'm here inside of Seattle, it's great to be able to go off and say, I want to pin the city. I'm going to pin this thing to the start. I'm going to pin this thing to the start. And when we come back, right, you'll be able to see somewhere down here at the end the secondary tile that would have been created. So why don't you tell us a little bit more, Pranay, about how you did this, how you did the video stuff, and how you did the secondary tile stuff.
You will be really amazed if I tell you how I did the videos. It's as simple as including HTML5 videos in your application. The standard HTML5 video tag that you get on W3C.org, that's the thing I included here. So this is the HTML markup that you see here on the screen. There are two divs, and inside each div there is a video tag. And I just say to my application that it should loop the video, autoplay it whenever it's ready, and mute it. And I am having two video tags because when you transition from one city to the other, so the video changes on the background. We have put in a little animation to do that, so that you don't see a flicker on your screen when it changes the video. And after including this in HTML, you have to do a little bit JavaScript code, which I will show you next.
Very cool. Awesome. Thank you.
There is one more code of JavaScript.
Sorry?
The JavaScript file.
Oh, thank you. Yes.
Yeah.
Yeah. Too much practice.
So what we have to do here is specify the source of video. Uh, um, I select the divs and the video tag inside them and set the source of the video for that. So that's about the videos, and the rest code you see is for animation. If you want to introduce that, that's just simply as doing z index changes and fade out animation. The other cool thing that John mentioned is about secondary tiles. So to do that, you have to do two things. First of all, you have to create a tile, and second, you have to pin it. So John, if you can scroll down. So yeah, for creating the tile, you have to use the start screen method provided with Windows APIs. It's very cool. You just have to specify the tile IDs and the short names and the images that are your logos and wide logos, and it will create the tile for you. And tile ID is the thing which it passes back when someone clicks on Anaheim. It will pass me back Anaheim, and I can display to the user that city. And the second thing is about pinning the tile. So you have to use the function in the lower half of the code. And yeah, that's right. And that pins the tile on the Mogo, and that's how you see it.
Awesome. Great. Thanks. So Lindsay, you created this application that allows us to go off and measure objects that are inside of photos. And so there's a couple of cool things you can do. Obviously, there's photos that kind of show up by default, and you also have the ability to go off and either import additional photos or even take a photo off a webcam. Can you tell us a little bit more about what you did in order to go off and create those two things?
Yeah, so like you said, there's two main ways to get photos into the application, and those two ways are the file picker and the webcam, which if you've been attending a couple sessions, I'm sure you've heard a little bit about. But yeah, when we were using them, we actually found they were really simple to implement, and it was really easy to get them working the way we wanted to. So this first code fragment shows the file picker. And as you can see, it's pretty easy to just declare it, and it only took a couple lines of code to get working, and it gets set up with everything you've seen the file picker do. You can pull from other applications, you can pull from your photos folder. One thing we found was pretty neat is, as you can see, the word thumbnail is highlighted in that line of code. We actually changed the file picker to be specifically for choosing pictures, so it shows thumbnail images instead of like documents. So there were a lot of things to do that were really easy that got it to be really effective for our purpose. The other, if you flip to the other code fragment, this was for the webcam. And as you can see, it's set up really, really similarly to the file picker. So the webcam was actually something we added really last minute to our application. And originally we didn't really want to put it in because we thought it would be kind of complicated to throw in. But once we realized what API call we needed to make, it turned it out to be really, really simple to add. And it actually comes with the entire environment and settings and all of that. So by adding these couple lines of code, you actually get the entire webcam editing experience, where when the user takes a picture, they can opt to set the resolution, set a lot of different things. They can crop it. And all of that comes for free just by adding the webcam camera capture UI call. And so that was really useful for us because it allowed us to add this feature literally in like an hour to our application, because we just figured out like what exactly we needed to do. So that's something that's really useful if you're planning on building an application that has webcam capabilities.
Very cool. So yeah, like you notice that the code over here, right, is very similar to the code over there, right, which is effectively the stuff that you wound up using, right, to actually take the photo that you got, right, either regardless of the source, and then just inject it into the canvas, right, that's on the page.
Yeah, the webcam essentially, you call the webcam and it returns a picture to you the same way the file picker would. So both of those handle photos in effectively the same way, which is really nice.
Very cool. Awesome. Thanks. So moving on to Uliana. Uliana created this application that you guys don't see on your slates, but what it does is it's a calorie counting application, right? And it's a calorie counting application that that looks really pretty and modern, and also has these really cool looking graphs that we see inside of there as well, and some plots both here and sorry, up in the goals section here. Right? You can see that I need to lose some pounds here, right? So I can go ride faster than some other guys up some hills in Microsoft. So so why don't you tell me a little bit more, or tell us a little bit more about what you had to do in order to create all of these charts and plots?
Sure. So we wanted to create a calorie counter that would let you see your progress towards your goals in a very nice eye candy kind of way. So we decided to use lots of pie charts and line graphs to do this. Instead of having to write all these graphic APIs by ourselves, we decided to use the Raphael JavaScript library, which you may have heard of. It's a really powerful library for doing SVG graphics in JavaScript. So it was as easy as just including the Raphael.js file and using the code directly, as you can see in this sample. So we basically just copy and pasted Raphael code samples, and it worked perfectly within Windows 8. So developers can just leverage existing JavaScript APIs and use them in their apps.
Very cool. Awesome. Thank you. So moving along, another really fun application that my kids love playing is flashcards. And one of the fun things about flashcards, of course, is you can kind of scroll back and forth, and you can see a bunch of things, and there's kind of a set of associated activities that come along with each one of these as well. So Melinda, why don't you tell us a little bit more about what it took in order to kind of implement this kind of functionality here?
We actually use the flip view control to do the backs and the fronts of the cards, and we have 2 flip view controls and show and hide, each one depending on which mode the user is in. Using the flip view control, you have a div and that holds it, and you pass a data array and a callback function, and you bind the two so that the flip view will call the callback function, which renders the divs for the data objects.
Right, so the rendering function is this guy over here, right?
Mm-hmm. And then if you scroll down a little bit.
This is the bottom.
Oh.
Yeah, I moved it to another file, sorry. I'm doing this too. Right, so this is the card renderer file?
That's the callback
yeah,
function.
Yes.
And then we bind it there in the flip view, right, and then attach it to the holder.
Right.
And that's all.
And that's it?
Mm-hmm.
Wow, that's pretty awesome.
Actually, really simple.
Yeah. Okay, cool, thanks. So, moving along, one of the other kind of fun applications that almost, you always use, this is like the hello world of any GUI, right, is to go off and create an application that allows you to paint on the screen. And so the kind of fun thing about Paint Play here is certainly we can see all the multi-touch capabilities sitting here in the application itself, right? So Nick, why don't you tell us a little bit more about what you had to do in order to implement the multi-touch stuff on the canvas so I can get these lines drawn.
Sure. So when we were brainstorming design ideas for Paint Play, one of the things we really wanted to hit on was make a great touch-first painting experience. And obviously a big part of that is multi-touch. 2 friends can paint at the same time. I know me and Melinda were making a volcano. And we were like doing different rocks. And so when we first created our app, we actually only had single touch painting. What Windows 8 does for you is it provides these pointer event objects instead of, say, a mouse event or a touch event. And what a pointer event is it's kind of an amalgamation of all the input that we would want. So it's the stylus and the pen, it's touch and it's mouse, all within one event. And so we got all that functionality for free. The basic algorithm for how we did this was you put a finger or you click, so you get a down event. Then you're in sort of a dragging mode. And then when you get move events, you know that you can add those points to your path and you can draw your stroke. And so this was good. So we automatically had mouse, finger, and stylus. But then what would happen if you did multi-touch was if you imagine a line here and a line here, the only thing Paint Play sees is point, 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 point. And so you get these crazy effects going on, which were actually kind of cool, but what we wanted was really 2 lines. And so what we had to do was we had to create separate paths for each pointer. And so behind the scenes, when you have more than one pointer, Windows 8 is actually parsing those out as separate pointers. It's saying, okay, this point's close to that point. It's probably the same finger moving. And it actually assigns a pointer ID to your events. And so if you look at the code here, the only code we had to add, basically, was the if statements, which kind of separates out the pointers. And then the draws, so the draw start, the draw, and the draw down, the draw stop, they also create separate paths based on that pointer ID. And that's kind of 3 lines of code, and you have multi-touch. So that was pretty cool.
Very cool. And the other cool thing that you have inside of Paint Play, right, is this kind of, this kind of cool looking color picker thing, right? So why don't you talk about how you kind of prototyped and built that thing?
Sure. So there obviously wasn't a color picker when we started designing this app. So we actually created our own custom control. And so what you see here is the first prototype we had, which we threw together with HTML5 and JavaScript and CSS3. And it took about half an hour. We kind of had an idea of what we wanted for a color picker. So I threw this together, sent it over to the other dev and to the project manager. And they didn't, the beautiful thing about HTML5 and JavaScript is they didn't need to compile it. They didn't need external libraries. They didn't need any development things. They ran it in their browser, and they could check out this little prototype I threw together. And so right away, I could just send them a couple files, and we could start discussing it. I mean, my mom could have run this code sample. And so what it allowed us to do, so there's the code. It's pretty simple. It just creates the colors, and then when there's a mouse hovering event, then it just kind of makes that box bigger. And it uses CSS transitions to smoothly create those changes in width. And then we send it over to the user experience guys. They did some usability testing, and eventually we tweaked it, and we got the color picker that you see today.
Very cool. Awesome. Thanks, Nick.
Thank you.
So Tad, you created an application called, with a really awesome name, right? Kokomo.
Yes.
And so Kokomo is a travel application. One of the things that you want to be able to do is invite your friends, right, to a trip as well. And so if I were to go over to your West Coast and say, hey, you know, there's this West Coast adventure thing that I have, I'd like to be able to invite some of my friends to come along. The cool thing is that there's, rather than inviting my friends by typing in like a gazillion email addresses or something else, instead it would be great if I could just pull in those friends from another application on the system. Unfortunately, we don't yet have an application that acts as a source of contacts yet.
Wink, wink. Plug for you guys to make it.
Exactly, right? You know, it's up for you guys to go off and build that in the future. But what we do have is we have a sample, right? So this is the UI, like the very non-professional looking UI, right, for our sample application, which allows us to say, hey, let's go off and, you know, select a couple of people that I would like to send invitations to. Click on send invitations, and you can see some toasts pulled up over here. So Thad, why don't you tell us a little bit more about what you had to do to go off and build those two features?
Yeah. So in my opinion, one of the most successful and strongest stories of Windows 8 is that it's making a huge bet on being social. I mean, every application you see today needs some social component to really thrive and build a strong community. And the hardest thing, the biggest barrier to entry has been getting people to want to invite their friends or to enter all the information required to invite their friends. But the Windows provides this really nice surface for us to create what's called a contact picker. And here we see it's really just 2 lines. It's actually 1 if you combine the 2. And it's really simple just to create a contact picker, customize it with whatever you want to say. You know, here we say that we only want emails, and then start the contact picker operation. And then following our nice little asynchronous model that we do in Windows 8, once the operation is completed, we're kind of alerted of what's going on, and then instead of having to, you know, parse, do weird things with commas, we get the information back in a super nice JavaScript object type notation. And then we can do things like send email and raise a toast to alert the user of what's going on. So switching to the next page, some of the things you might want to know about Windows 8 has to do with user interaction and outward-facing UI. So we often want to let the user know what happened, or we want a convenient way to give some transient information. And Arturo talked earlier about scheduled toasts and scheduled notifications, but if we want to do it right away, we can just raise a quick local toast. It's as easy as, you know, getting the toast template. This time we use the second one. You can use the first one if you like, but it's just whichever one fits your need. So then we get the template, we customize it with whatever we need, and we say show toast notification, and it's really as simple as that.
Awesome. Great. Thank you. Again, back to the kids. Everything seems to revolve around my kids. So another application that my kids really like to play is Treehouse Stampede, right? And it's kind of hard not to like this app, right? Because there's these crazy-looking fuzzy things that are coming along and trying to attack you in your treehouse. So one of the kind of key things about what this game was all about, right, is to kind of demonstrate the use of the on-screen keyboard, right, and to get people to play with it so they can learn how to use it. So why don't you tell us a little bit more about the kind of challenges that you had in kind of building a game like Treehouse Stampede?
Yeah, so that was loud. So, the Windows on-screen keyboard is really intelligent most of the time about, appearing when you want and, going away and sort of staying out of your way. But in something like Treehouse Stampede, we wanted the keyboard to stick around all the time. We don't want to, if you click the skip button, you don't want the keyboard to go away. And
the passe button.
Oui, John. And, so what we really did in this is it takes a little extra legwork to get it to stick around. So we essentially have 3 layers in our application here. We have the canvas and everything that we don't want the user to really interact with, so where all our drawing happens. And then on our second layer, we have a giant invisible div that you can't see. And then we take over the on mouse down event and return false. So that way if the user taps or clicks on this giant invisible div that they can't see it cancels the event bubbling, and so then your focus will stay in the input field. And then for stuff that you do want the user to interact with, stuff like the input field or the skip button, then we have that sit on top of this invisible div. And we use the z-index CSS property for that. And so you can see on the input box, we don't do anything special. But then on the skip button, we take over the mouse down event again. And then we do all of our skip click stuff. And then again, we return false so that focus stays in your input box. It's
right,
really
so return false is just canceling the event bubbling thing, right? That
Exactly.
we've always seen in HTML5 before.
Yep.
And so the other kind of funky thing that we saw about Treehouse Stampede was it was in this other language. And so why don't you tell us a little bit more about what it took for you to localize your application, right? To have it in French as well.
Yeah, I was less than impressed when I heard that I had to do localization because you think it's going to be this really complicated process where you have to have a file and you have to get all of your strings out of it, but Windows actually made it really painless to do this. And so you can see here we have our skip button, and we just have this little tag for data winres, and that stands for our resources. And we just say text content skip, and then if you head over to our resources file, we just have this skip string, and it just corresponds to some text, and you have a comment for your localizer, and then you just put your text in there. Windows does all the rest for you.
So I guess the key thing is that, for the English text, right, it sits inside of the EN folder, right? And,
yep.
And you had some text that you guys wrote as well, right, in the FR folder?
Yeah, so then you would just put it in the FR folder for French,
yeah.
And that's where all our other strings sit.
Cool, awesome, great, thank you. So moving along, so Purva, you had an application that was that lots of people, I'm sure, played with a lot. We've certainly seen this in many different times in various talks throughout the conference. One thing that folks may not have noticed about Word Hunt is that it's paused. And we will run it again. The cool thing is that you also have the ability to have like this multiplayer mode, right? And the kind of key thing about being able to play Word Hunt inside of a multiplayer mode is to be able to send data and communicate back and forth between the two different machines. So people are essentially competing, right, to see how many words they can do versus their opponent. But clearly you must have been like a networking guru, right, in order to go off and build this thing, right? So why don't you tell us a little bit more about how complicated that was and what you had to do.
Actually, John, I came into Microsoft almost not knowing any networking at all. And it's not that I'm a genius, but rather that Windows actually made it really easy and kind of fun to implement networking using their APIs. So my partner, Tyler Dunn, actually helped me implement near-field proximity similar to the Bitbox folks. So what I'll talk to you about instead is the StreamSocket API, which actually lets you read and write to sockets, like, for example, the proximity stream socket. And the API just makes it really easy to pass data back and forth between multiple devices. So the way my app is set up is if two people are playing against each other, then each app will have a client object, and one of the apps will also act as the server, so it'll have a server object. And both the client and the server objects will have a reference to this command reader object that you see a snippet of on the screen here. And basically the reason you need a command reader is so you can construct meaningful messages that you're passing, like structured messages that you're passing back and forth, and it also makes sure that all of the messages are in sync. So you pass it the socket and the callback function, and you want to pass it the callback function because you know both the client and the server will have different functions that it'll want to run when they're getting commands. And so as you see, when you start the command reader, it'll start the load async function. And what that means is that whenever the socket receives some bytes, it'll asynchronously call the have bytes function. And from there, it'll take whatever the data it has and parse it into a command. So you'll probably need to write a command function that kind of initializes the header, that indicates, how many bytes you're sending or what kind of data it is. But all of this framework, you just need to write it once, and then you can use it in all of your networked applications. What's really cool about all of this is that I use this to implement the two-player game, but I could keep the same thing even for the single-player game. So in the single-player game, I would have an app that has a client and a server object as well. But instead of using a proximity stream socket, I just have a stream socket that works with like a loopback. Now, John, I know you're itching to run off and create some of your own networked applications because this is just so cool.
Even I can do this?
Yes, even you can do this. But in case you need, a little more guidance, then you can refer to the stream socket sample online. You can also view the videos on the talks already given, 785 on creating connected apps that work on today's networks, as well as talk 580 on making Windows runtime socket apps.
Okay, awesome.
Good luck.
Cool, thank you. Aha. So Matt and Diggy, as well as Noam, right, who's not here with us today, created this really kind of fun application that hopefully you guys have had a chance to play, and that application is Labyrinth. And so hopefully you guys have seen this guy by now, right? There's a lot of kind of fun and funky things about Labyrinth, right? You've got this ball, and it plays music, and it stops, and all. But it's awesome in the kind of gameplay and the sets of things that you wound up building around Labyrinth. So why don't you guys talk a little bit more about what it was like to build this game, right? Because a lot of people would think that a game like Labyrinth must be like some C++ thing, right? But instead it wasn't.
That's true. Like when we started with the concept and started thinking that if we want to implement a game like this, we were really skeptical that to implement something like this in HTML, JavaScript. But actually, we are at the game, the gameplay. That's an HTML5 canvas, and the reason we were able to pull off a game like this using HTML is because of the hardware acceleration that is going on behind the scenes. So actually, what you get is that Windows like IE10 provides this you just use your HTML as a web developer. You use all your knowledge and put it in here, and you get all this acceleration for free. I would like to refer to this as you saw in the keynote by Steven Sinofsky, where he had like hundreds of dots rolling around his hands, and that was pure hardware acceleration. So I want to break the ice over here and tell the developers out there that you can use your knowledge of HTML5, and this platform will really give you a lot of power on that. Also, there is one more thing going on behind the scenes over here, and that is asynchronous calls. Traditionally, JavaScript is just one thread, although you can have web workers, but they have very limited work. Over here, all the things are going on asynchronously, and we are calling asynchronous calls. So that's why the game flow is so fluid and so smooth, and that's why it's so amazing.
So Diggy, this is probably like consuming all the CPU cycles on my machine, right? As you imagine, to get this kind of frame rate. Why don't you tell us a little bit more about what your observations were, especially when you tested on different hardware?
The thing is, we ran our game on ARM architecture, and what we surprisingly found was that we were actually getting better performance on ARM architecture, most likely because a lot of the work was actually going to the GPUs, and the performance was amazing. We were not eating out your battery, believe me. And that's what I want to say, that you can really push your limits now, and you can create games which are much more intensive, and you can really use the platform. At the same time, I use any other, like a traditional web developer would do optimization. We also did something similar. In our game, we were using canvas partial rendering So that's a standard HTML5 API where we render only the region around the ball and we only update that part, and that too is hardware accelerated, so we use minimum of our CPU and we are able to pull this off. Again, another thing for game development is you require precise timing, and we are using request animation framework, which is again an HTML5 standard, and so you can use your web knowledge and you can just create, you can expand your horizons on this.
Very cool. Awesome. Thanks. So Matt, why don't you tell us a little bit more about, like during the development of your application, there was a couple of things that that you guys were trying to pull together as well. What happened during the kind of transition, right, between, like from the concept, the idea, the set of things that you're thinking about, and then initially, right, before you actually had access to the sensors, you actually drove this as a keyboard application, right? And then, at some point you had to switch over to the sensors. Why don't you talk a little bit more about that?
Correct. So we started out developing Labyrinth by sitting down and brainstorming the experience that we wanted to create. And so we sat down, we came up with the look and the feel and the animations and the coloring, and we even composed our own music for the application. And then we took those ideas and we started to implement them, like you said. And so at first we started using the arrow keys, and which still work if you don't have an accelerometer hooked up. And so we started with that, and then there came this point in our project where like, okay, we are ready now to switch over to sensors and kind of take the user experience to that next level. And so we're in the back of our mind, we're like, okay, so how difficult is this going to be? None of it, well, Diggy has some sensor background, but Noam and I, we were kind of like, oh, well, here we go, let's just jump in. We found out it was super easy. All it took was 3 lines of code to go in and create an accelerometer object and use that accelerometer object to pull the vectors in X and Y, and just use that in our application. Literally, it was probably 15 minutes. We went from arrow keys to sensor input, and it was awesome. We were all freaking out. It was a lot of fun.
Very cool. Awesome. Thanks, guys. So finally, the last application we'll see tonight is the aircraft application. And unlike, this is a slightly different version of the aircraft application than perhaps you guys have seen on your tablets. You'll see here, like, whoa, there's a couple. Because these guys have been busy hacking away at the conference, right? Adding more features to the application, so we can show you this really polished version of it today. So there are a couple of really cool things about aircraft. One cool thing about aircraft is, hey, you can get to this thing here, but then I can go off and take my finger on the stage and kind of rotate this guy around in 3D. And the other thing that you notice is that it's this very kind of fluid and smooth animation in there. So, Zach, why don't you tell us a little bit more about what you had to do in order to kind of implement the kind of like the smooth panning and the animations and that.
That's right, the fast and fluid.
The fast and fluid.
So definitely, if you take a look at the beginning of the application, we had that nice little spinner. Everything was nice and smooth. We have that nice smooth fade-in animation. But it wasn't always that way. If you look at this code sample right here, this was what we basically started off with. Pretty standard stuff. I mean, everybody codes this way. You go get the files you need to load. You go through, you load them, you parse them, and then you go on your way. The problem we noticed with this was that this could take a while. And when we're doing this in JavaScript, everything's running on the UI thread, and we'd lock it up, and we were no longer fast and fluid. So we were talking to some people, and we decided to use the promises from the Windows JavaScript library, and that really made a huge difference. And thankfully, it wasn't a whole lot of work for us, particularly because the logic is the exact same. You basically just split up your individual work items into more or less self-contained chunks, and then you can schedule them asynchronously. So if you look here, we basically just create a promise, and then we can go through in that promise and build individual async operations to go do something for each of the files. And then if you look at the bottom, we simply just wait for all the files to be done loading, and everything is done asynchronously, and we get to stay nice and smooth.
Very cool. And what about some of those animations, right? Like, how did those planes move around in 3D and stuff like that?
Yes. So thankfully, the Windows JavaScript libraries have an awesome set of animation utilities. And we originally wrote our code just kind of using set interval and set timeout and manually going through and animating each of the HTML elements. But we wanted it even better, so we switched to the Windows JavaScript animation library, and that gave us the hardware-accelerated animations that everybody was talking about, and that really made a huge difference in the user experience.
Yeah, very cool. Awesome, thanks. The other cool thing that we have inside of Aircraft is the fact that, if you were to think about an application, and you think about this as an HTML application, and you say, let's go off and print this thing, you would print what you would see on the screen. Right. But there's a bunch of other kind of cases where, I might want to print something a little bit differently, right? So for example, if I wanted to view the instructions on how I can go off and fold the plane here, right? One of the things that I would like to be able to do is print out that instructions, but not the way it is on the screen, right? But instead in a layout that would kind of make sense. So if we were to go off and look at what happens when we print this thing, there's this completely different view, right, that we wind up getting out of this, where everything sits on a single page, right? And we can see it previewed and rendered over here in the print preview plane. So now why don't you tell us a little bit more about, what it took for you to go off and implement that feature?
Sure. Yeah, so like you said, it's really easy to print exactly what's on the screen, but we wanted to have that other view, as you saw there. So what we did was we registered for the before print and the after print events. And on the before print event, you can see that we added this other HTML content to the document. So that way, when we printed, this content would show up. And so then in the after print, we removed that content so we didn't have it hanging around, taking up memory, because we didn't need it. But the problem with this was that then we have two things. We have something we want to print and something we want to show on the screen. And those would both be showing on the screen and both be showing in print. So we used some CSS media styling to hide things for print that we didn't want and hide things on the screen that we didn't want. So like the instructions that were on the screen were in our div manager container, you can see here. So we don't want those to show up when we print it out. So we just use the CSS media type for print and hide that on the screen, or hide that for print, sorry. And then for the print content, we just hide that on the screen. And so it's a really easy way of kind of making two separate documents, but they're still all in the same document object.
Very cool. Awesome. So this was the essentially the applications that we had. We thought this was really awesome. I think we should all give these guys a great round of applause for the stuff that they were able to do. And before we leave, since you guys have to do the next thing, which is go off and create a bunch of applications for us to see in future presentations from you, we thought we would leave you with a little parting gift, right? Produced courtesy of the aircraft application with custom messages, personalized messages from each one of the interns to all of you. So cover your eyes, don't get hit, please, right? And there we go. Let's finish it off. Woo! Thanks, everyone.